Writing functions helps us set up equations in the context of a situation. So by writing a function, you're able to figure situations out mathematically. So you can set up a function to figure out how much money you could make. For example, if you made $7 an hour babysitting, then you can create a function. So y equals $7 times x, which is the amount earned would be y, is your equal sign, $7 is still $7, times, and then the number of hours that you work. So your amount earned is always going to be $7 per hour you work. Alright? So your function ends up equaling y equals 7x. Well, with this function you can quickly determine how much money you could make for any number of hours. So you can create situations from words, you can create situations from tables and graphs, or functions from situations, tables, and graphs. So if you're given a table such as y equals 1, 2, such as x equals 1, 2, 3, 4, and y equals -2, -1, 0, and 1. This is still an XY chart just like you've seen before, it's just sitting sideways. So when you have a chart like this, you can find the function. So what you have to do first is list some different possible relationships between the first order pair. So I'm looking at 1 to -2. So what could I do to an x to get to y is what I'm asking myself. What can I do from 1 to get to -2? Well, one thing I could do is I could subtract 3. So 1 minus 3 equals -2. The other thing that I could do is I could multiply 1 times -2, and that'll give me -2. So my two options are 1 minus 3 equals -2 or 1 times -2. So what I could do next is test all of the other points and see, is it going to be a subtraction relationship or multiplication relationship to get it right. So 2 minus 3, 3 minus 3, 4 minus 3, and it's got to be the same number every time. Whatever you're doing to this first one is what you've got to do to all of the others to see if it'll work. So up here I multiplied -2. So 2 times -2, 3 times -2, 4 times -2. And I need to see if it'll equal the y values that they gave me. So up here I had 2, -1. So when I take the 2 and I subtract 3, do I get -1? Yes. Over here, when I take the 2 and I multiply times -2, do I get -1? Well, no, you don't get -1 at that point because 2 times -2 is -4. So 3 minus 3 equals 0, which is the y value from the chart, and 4 minus 3 equals 1, which is the y value from the chart, but multiplying by the -2's didn't work. Alright, so keep in mind the test does not change. That's what I was saying a minute ago. So it's always -3 or it's always multiplied by 2. And then step 3, replace the changing values, or the changing x values with an x, and the changing y values with a y. So here's my x right here. These were my x's, what I was doing to it in my y's. So my function is x minus 3 equals y. And now for any x value, I can find the y value. Alright, so there's two types of variables. There's your independent and your dependent. Input is your independent variable, and your output is your dependent variable. So basically, these are all your independents are all your x's, and your dependent variables are your y's. So let's go back to that babysitting example. The amount of money that you make.
Please come to admin 1.
The amount of money that you make is y.
Aunt Cholula, please come to admin 1.
And it depends on the number of hours that you work. Sorry for that interruption. So the amount of money made depends on the number of hours worked. So this is my output. This is what comes out when I plug in different numbers for x, when I input different variables for x. So this one's independent. I can choose to work 4 hours. You could choose to work 20 hours. However many hours you choose to work goes here. And then the amount of money that you make depends on how many hours you chose to work. So to write a function, you need to identify which variable's dependent and which one's independent, and then write the equation that models the situation. So let's take a look at a lawyer that charges $200 per hour for her services. So the number of hours is independent, and the amount of the fee depends on the number of hours worked. So what happens is a lawyer's fee is dependent upon the independent amount of hours that she works. She could choose to work several hours or no hours or a few hours. So H is going to be my number of hours. That is going to be my independent variable. So that's going to be the one on the right side of the equal sign. And then F of H okay, f of h is the same thing as y. This is a different notation, okay, but it's the same thing as y. That's going to be the phi that she makes. The reason this notation is used is it's a function that's using, this identifies it as a function that's using h as a variable. So we're creating a function, and the correct words for it is we're creating a function in terms of h. Okay, so it tells someone, a math person who is looking at this, that it is a function and that h is the variable that you should be looking for, that it's going to be changing. So f of x is what you often see, and it's said like that, f of x. That's not f times x, that is f of x. F of x is a notation that is often used and interchangeable with y. So everywhere you see a y before, you can actually write f of x in its place as long as x is the variable that's being used. It identifies a specific function and the variable that's used in the function. F is just the way to identify a particular function. You could have g of x, h of x, I of x, m of x. So you can have all these different letters to represent different functions if you need them. The reason f is used often is because it's short for function. All right, so this notation helps you see where to plug in numbers if you're asked to evaluate a function. So if you're given f of x equals 2x plus 3. Now you've seen y equals 2x plus 3 a whole bunch of times, but f of x equals 2x plus 3. Well, what it does is you evaluate f of 2. So you replace the x. Well, that helps you remember, well, I need to replace my x's. So I'm going to replace all of the x's. If I replace this one with 2, I want to replace that one right up here with 2 as well. So it becomes 2 times 2 plus 3. 4 plus 3 is 7. If I asked you to evaluate f of negative 1, I'm going to replace the x with negative 1. So I'm going to replace the x right here with negative 1. Negative 1 times 2 is negative 2 plus 3 is 1. F of 5, I'm replacing both of my x's with 5s. Here's the first one I'm replacing. It's your instructions. And then I'm going to plug in the 5 at everywhere else I saw an x over here. So 2 times 5 is 10 plus 3 is 13.